So we continue with our discussion on stock valuation or valuation of common equity of a company under Unit 2. We've already seen two cases under valuation of common stocks where we had first assumed a single dividend and next year price, and case 2 where we had assumed a dividend and a price at the end of a few years if the business closes down after a few years, right? Now, in case 3, we will remove these two assumptions and we will bring in the assumption that the company actually survives till infinity, right? So usually a company is expected to be a going concern, which means it is expected to last till infinity, and thus there is no way of arriving at a final value, right? So you cannot find or claim that the company has sold or shut down its business at the end of a particular period. You will have to kind of mathematically try and find an equation that gives you the price of the stock. Now, luckily for us, mathematically this is possible to do, assuming that we assume a steady growth rate for the company's cash flows, right? We have to assume a single growth rate for the company's cash flows till infinity, and then mathematically it is possible to solve this, right? Let's see how. So if the company makes a payout every year, this is the cash flow that needs to get evaluated every year, and value of common stock is the present value of all the cash flows till infinity, right? Now, what we're going to believe or assume is that each cash flow is the last year cash flow growing at a certain growth rate G, right? So we'll assume that, let's say these cash flows are the dividends. Assume that the dividend is growing at a constant growth rate G, right? And so if last year dividend was D, this year dividend is D into 1 plus G. Next year dividend is D into 1 plus G square, D into 1 plus G cube, so on and so forth till infinity, right? And if you find the present value of all these, that's 1 plus R, 1 plus R square, 1 plus R cube, and so on and so forth till infinity, right? If you look at this closely, each term is arrived by taking the previous term, right, and multiplying the previous term by 1 plus G by 1 plus R. See how this comes. The first term is D into 1 plus G divided by 1 plus R. Now you multiply this with 1 plus G upon 1 plus R, you get D into 1 plus G square, 1 plus R square. That's the second term we found. You multiply this with 1 plus G by 1 plus R, you get D into 1 plus G cube upon 1 plus R cube. That's the third term. So every term is being calculated as the previous term multiplied by 1 plus G upon 1 plus R, right? This 1 plus G upon 1 plus R is the common multiplication factor that we are using. And this is forming what is commonly known as an infinite geometric progression mathematically. A geometric progression typically takes the form of AK square, AK cube, and so on and so forth, where every term is multiplied by the previous term with a common factor, right? The previous term multiplied with a common factor k, then a common factor k, then a common factor k will keep giving subsequent terms, right? For example, 1, 2, 4, 8, 16 is a geometric progression. So that's what is a geometric progression. We have an infinite geometric progression here. Now, mathematically, it is possible to find the sum of an infinite geometric progression, right? The sum of an infinite geometric progression, which is given as AK, AK square, AK cube, and so on and so forth, is given as A divided by 1 minus K. That's the sum. A being the first term, where A is the first term in the series and K is the multiplication factor, right? So what is, in our case, what is A? A is the first term. So this is the first term. A is equals to D into 1 plus G upon 1 plus R. And what is K in our example? K is 1 plus G upon 1 plus R, because every term is getting multiplied by 1 plus G upon 1 plus R. So what is the sum? The sum of the infinite GP is given by A upon 1 minus K, which is nothing but D into 1 plus G upon 1 plus R. That's A, that's the numerator, divided by 1 minus 1 plus G upon 1 plus R. Correct? That's the value we get. This is the entire formula that we get. Now let's take this formula further. So we open the brackets and we try and see what happens in the denominator. So when we form the denominator, it becomes 1 plus R minus 1 plus G divided by 1 plus R, right? That's how we do it. So this and this will cancel each other. And when we open the bracket, what will come is dividend into 1 plus G. Again, 1 and 1 will cancel each other, divided by R minus G. That is what we get essentially in terms of the summation of the final value. Let's redo this once so that we don't have any kind of confusion. What we are saying is that the sum is given by A upon 1 minus K. A here is D into 1 plus G by 1 plus R, and K is 1 plus G by 1 plus R. When we solve for this, it gives us D into 1 plus G divided by R minus G. Right, so that's the calculation formula. We can try and simplify this and work this way. So let's take this once again, D into 1 plus G divided by 1 plus R divided by 1 plus R minus 1 minus G. Have opened all the brackets by 1 plus R. 1 plus R and 1 plus R cancel each other. Minus 1 and plus 1 cancel each other. What is remaining here in this formula is what we get here, right? That's the formula that we get. Dividend into 1 plus G upon R minus G, or in other words, sometimes some textbooks also denote this as D1 upon R minus G, D1 being the dividend next year, right? Because the growth rate will take dividend into 1 plus G will give me the dividend next year, divided by R minus G, where R is the expected return, G is the expected growth rate, steady, stable, constant growth rate, right? That's what G is. And based on this, we can arrive at the price of a particular company's stock. So that's basically the approximation that comes based on what is the price, because this is how the sum of an infinite geometric progression is taken. Let's take an example. Assume a company with a dividend of rupees 4, growth rate of 8%, required rate of return of 15%. The stock price could be derived using this formula. So dividend is 4. Next year dividend will be 4 into 1 plus 8%. That's 1 plus G divided by 15% minus 8%. That should be the price of the stock. Let's try and solve this using our Excel file. So that's the question we have. Dividend this year is 4. Let me rewrite the formula here as well on the right side. So we are saying dividend into 1 plus G divided by R minus G. That's the price of the stock. Let's put in dividend into 1 plus G. So in a bracket, 4 multiplied by 1 plus 8%, bracket close, divided by 15 minus 8%, R minus G. And 61 rupees is what the share price should be. 61.7 is what the share price should be based on this calculation, this formula. So if we are given the company's dividend, which is a stable period dividend, and we are given a steady growth rate till infinity, and we know what is the expected rate of return, we can find out the price of the stock. We can conversely also try and find out what is going to be the rate of return of the company's a required rate. What is going to be the rate of return if the stock price is available with us? If the price is available with us, then it becomes easier for us to calculate the rate of return for the company, right? That's what is used for this calculation. Let's go back to our discussion and move to case 4, where we relax our final assumptions as well. Now, one of the assumptions we've made is that the company gives dividend. Now, what happens if the company actually does not give any dividend? If the company does not give any dividend, that does not mean its value is zero, because mathematically, in whatever we have done so far, the value will become zero if it does not give dividend. Dividend payment that is not happening, it's a choice, and the company might be reinvesting in the growth of the business. It's quite possible that the company is growing fast, and hence, rather than paying money to the stockholders, they might be reinvesting it into the business. They can do that. If the growth rate of the company is good, it might make sense as well. In such cases, we have to use a proxy for dividend in order to value it. We can't use dividend because there may be no dividend or very little dividend, and if that is the scenario, then we can't get the value as zero. We use some proxy for dividend, which is called as free cash flows, right? FCF. And we replace the free cash flow in the equation where the equation is available. Exactly the same scenario. Whatever is the free cash flow for the year will replace the dividend in the equation. 1 plus G divided by R minus G. Now, what is the free cash flow? Free cash flow is effectively the capacity of the firm to pay dividends. Whether or not they pay is immaterial, but this is the amount they can pay as dividend. The firm can pay this as dividends, right? So this is the total capacity of the firm to pay dividends. That's what is known as free cash flow. How do you calculate free cash flow? That's, you start with simple calculations of your cash flow. More or less the same calculation works here, just that you do not use the adjustments made for equity, right? So free cash flow, and I'm using free cash flow as a term for equity holders. There is also another variant of free cash flow which we will discuss at a later point of time. Free cash flow to the equity holder is calculated as net profit. You add back depreciation because it's a non-cash charge which you had already deducted. So that's not gone out of the cash flow. You remove the changes to net working capital, right? Just like we construct our cash flow using the indirect method, that's what we do here. You remove all the capital expenditures on account of capacity expansion, etc., that the company would have done, and general wear and tear kind of replacement that the company would have done. And if the company has raised any debt, changes to that net debt number will also kind of come in here. If you calculate all these data points, that's effectively what is the capacity to pay dividend. This is the amount of cash which is available with the firm, free cash which can be distributed to the shareholders, and technically the entire amount could be given out as a dividend. Whether they choose to give it or not is a different issue altogether, right? So let's understand this as well using an example, and that will make things clearer and better for us to understand. Let's go back to our Excel file and go to stock valuation 4. We have a company whose data is given. Net profit is given, depreciation is given, net working capital is given, capital expenditure is given, change in debt is given. We have to calculate the free cash flow and then use the formula, right? So first let's list down what is plus and what is minus here. So this is plus, this is plus, this is subtracted, capital expenditure is subtracted, and change in debt is added, right? So let's do that. 120 plus 35 minus 24 minus 30 plus 10 is going to give me my free cash flow, right? That is the free cash flow to the firm that we have, free cash flow to the equity holders that we have calculated. Now, what is the formula? We just replace dividend by free cash flow. So we will take free cash flow into 1 plus growth rate divided by R minus G. That's the formula that we have to use. Let's use that formula in terms of the value of the company equity. That's 111 into 1 plus 5%, which is assumed to be the growth rate of cash flows here, divided by 14%, which is my required return, minus the growth rate, which is 5%. And we find that the value of the company's shares, total value of the company's equity, will arrive as 1295. Assuming that the unit here was rupees crore, the total equity value of the company will be rupees crore. And then if you have been given number of shares of the company, you can divide that to find the per share value, right? So you can divide that to find the per share value of the company's stocks, right? So that's broadly how you would calculate this kind of a calculation in terms of usage of free cash flows to the company, right? That's the calculation on free cash flow. Now we move one step further. We move one step further in terms of our discussions, and it's always dangerous to assume that a company will grow cash flows at constant rates steadily from now on. In fact, if the company is small, it might be useful to assume multiple stages of growth, right? A typical two-stage growth rate model would assume a DCF model would assume a high growth phase followed by steady growth rate. Take a look at this. Let's assume a company grows at a rate high growth, HG being the high growth rate for n years. So this period here, this entire period here is the high growth period. And beyond this, the company grows at a steady rate. And the value of all the cash flows after this is added into this calculation, which is what we just did, right? So cash flow into 1 plus G upon R minus G is the sum of all cash flows till infinity. And that's here in the last year, right? And these are available as the values which are there. Remember, this final value is in the last year. So technically, to find its present value, you have to actually divide this also by 1 plus r to the power n, because in the nth year, you will get this value. If you're standing today, this is the value of all cash flows from now till infinity. If you're standing in the nth year and cash flow there is this cash flow, then the sum of all the cash flows after that is going to come in the nth year, right? That's the cash flow valuation in a multi-stage model. Let's take an example of this as well. So we go back to our Excel file and we see cash flows at this point of time are 100. Growth rate for 3 years is 15% and steady growth rate is 4%, right? So let's first find out the cash flow here. Today the cash flow is 100, which means next year would be 100 into 1 plus 15%, correct? And we can freeze 15%. And then it would be this into 1 plus 15%. And so on and so forth. So the third year cash flow, so for 3 years, these are the cash flows which are available. Now, in the third year, if the cash flow is 152.1, let's call this CF. The terminal value will be nothing but this into 1 plus the growth rate, which is 4%, divided by expected return R minus the growth rate, which is this. And so that's the value of all the cash flows till infinity. Now, this terminal value is actually in year 3, right? So if this is in year 3, then technically to find the present value, this also has to be discounted by 3 years, right? Let's find the present value, 115. So that's 115 divided by 1 plus the rate expected return raised to the power 1, close bracket, and we just freeze the rate of return, drag it till here, and in the final case we divide this as well by 1 plus 13% raised to the power 3. The last one is, remember, in the third year, so we calculate that as well, and we reformat this in our existing format. Total equity value for the company would be sum of these cash flows. That's 1529. That comes by taking the sum of these 3-period cash flows, which are the high growth period. So this period here combined together is what is the high growth period, and this terminal value here is the steady growth period after this. So essentially all the cash flows put together eventually give us the values in terms of present value. Just be careful that the terminal year value is the last year's cash flow, so effectively you have to discount it by 3 years in this case, whatever the number of years. If the growth rate high growth period is for n years, the terminal year value has to be discounted by n years to reach the present value calculations, right? That's in a nutshell how you would go about valuing stocks using discounted cash flow valuations. In our next session, we're going to discuss the valuation using something called as comparables or multiples.